Welcome to another Mathcast. In this episode, we're going to be taking a look at how to use the dsolve and DEplot commands. So I just have an open Maple document here, and if it's your first time using Maple, a couple of things you might want to know is switching between text mode and math mode. Currently, you can see that because I'm in this little bracket here that I'm in math mode. If I switch to text mode, you don't see the little square surrounding it. I'm going to switch back to math mode for most of the stuff that I'm going to do in this presentation, but I will use text mode a little bit just to show you how to switch back and forth. A couple of things I need to do from the offset is load a couple of packages. I'm going to start by loading the DEtools package. And in Maple, if you don't want to have a bunch of stuff show up, you can use a colon at the end of it to suppress the output. So if I just hit enter without the colon, it's going to list a bunch of packages for me, which is really going to clutter up my screen. So rather than do that, I'm going to hit a colon at the end of it to keep that output suppressed. I also want to load the plots package, and I'm going to suppress the output on that as well. All right, in this particular example, I want to take a look at the falling body problem that we did in class. And so if you recall from that problem, we had a couple of different constants. We had the gravitational constant, which is 9.8. So I'm just going to set that to the constant g. Notice how I'm doing colon equals to assign variables. And then I'm going to set the mass equal to 10. And I'm going to call the air resistant coefficient, which was gamma in class. I'm going to call that A here. Gamma is a protected constant, so I can't call anything gamma in Maple. But I'm going to call A, I'm going to let that air resistance be 2. And what I'm looking for here is the ratio of M to A to be 5. So that's why I did 10 to 2 in this case. That way it'll match the graph that I have in the lecture slides. All right, let's suppose that out to the side of A I wanted to write in text what that variable is. To switch from math mode to text mode, all you have to do is hit F5. So if I hit F5, notice it switches me into text mode, and then I can just write out to the side that this is the air resistance coefficient. And writing in text mode doesn't affect any of the math that you're going to be doing. All right, I skipped down a couple of spaces. I want to go back into math mode, so I'm going to hit F5 again to put me back into math mode. And here I'm going to introduce your first command that you need to know how to use this semester, and that is the dsolve command for differential equation solve, so dsolve. It's all lowercase, and then what I want to do is I want to actually solve in general that equation that we looked at in class. So if you recall, the differential equation wound up being the following. So there was our differential equation. It was the mass times the derivative of the velocity equals the mass times the gravitational constant minus the air resistance times the velocity. Now notice, both places where I used the velocity, I had to write it as a function of t. That's something that you'll get used to as we do more and more examples throughout the semester. I can't just write v. dsolve needs to know what both my independent variable and my dependent variable are. And then finally, I'm going to tell it what quantity I'm solving for. In this case, I'm solving for v of t. If I close up the parentheses there, that's all you need. If I hit enter, what it's going to give me is the general solution. So the general solution here is nothing more than a decaying exponential. Notice it's got this constant underscore C1. That is times a constant. So the way to read this would be 49 plus a constant times e to the negative 1/5t. All right, if you recall, this was an initial value problem in those lectures, and so I want to actually solve the exact same thing, except this time I want to set it equal. I want to solve for the constant, so I want to have an initial value in the problem. In order to add an initial value in the problem, I'm just going to come back up here and grab the equation I just did, copy that, and paste it in. And what I need to do is enclose it with a curly brace. And inside the curly brace, I put both the equation and the initial condition. I'm just going to pick a value here. I'm going to suppose the initial velocity is 10. So I'm going to group that inside the curly braces, and once again, we're going to solve for v of t. Now, when I hit enter, what you're going to notice is that the general solution in 1 is replaced with a particular solution in 2, and that particular solution corresponds directly to the initial condition that we've specified. Now let's suppose that I wanted to actually plot that solution and take a look at it. I can do that rather easily by using the plot command. And then here's what I need to do. I need to go back up to 2, and I want to grab just this part. So I want to grab the right-hand side of that part, because if I try to plot the v of t as well, it's not going to know what to do with it. So here's the easiest way to do that. Come back over to my command here and type in RHS, that's the command for right-hand side, and I want to tell it take the right-hand side of number 2, so the output 2. The way you do that is by holding Command L, or if you're on a Windows machine, Control L. So Command L is the label, and I'm identifying label 2. So this literally says plot the right-hand side of output 2, and I'm going to plot it for the first, let's say, 40 seconds. And I want my Y values on the plot to range from 0 to 55. Close that up and hit enter, and we now have a plot. So notice I was able to specify the horizontal axis and the vertical axis separately. You can do ranges of values by putting 2 dots in between the values that you want to range over. And so that's a pretty nice plot. However, maybe I want to solve this problem for a lot of different initial conditions. So let's set up a bunch of initial conditions. I'm going to name the set of initial conditions I want to solve for IC. And here's how we do this. Every initial condition in Maple needs to be entered in square braces. And so I'm going to go ahead and write the command down and then try to explain the command structure to you here of the sequence command. The sequence command is one of those commands that we're going to be using off and on throughout the entire semester, so it's a good idea to introduce it now. So here's how this command works. It's going to iterate on I, meaning it's going to take and replace this I here with -5 to 5. And that's integer values because it's a sequence. It's integer values -5 to 5. So for example, the first thing in the sequence will be v0 equals -25, v0 equals -20, and so on. Let me go ahead and show you the output here so you can understand what it is that we're doing. I'm doing a list, which is the outer braces that I use, and then within the list are these tags for the initial condition. V of 0 equal -25, V of 0 equal to -20, all the way up to +25. So that's a list of a bunch of different initial conditions. Alright, I can't use dsolve, and I certainly don't want to set up a bunch of different plots to have to come up and solve the equation for each and every one of those and do a separate plot. Luckily, there's a command that we can do everything I just said all in once plus a whole lot more. And this is the most important command I'm going to teach you this semester. And that is the DEplot command. DEplot is the way to start it off. And for this command, it basically works the same as dsolve. In other words, I'm going to put in the differential equation that we were solving in class. And so far, at this point, if I was to stop here, there's absolutely no difference between this and dsolve. Here's the difference. Not only is it going to solve the equation, but now I'm going to tell it how to plot the answer. So I'm going to tell it, okay, I want you to plot the solutions for the first 10 seconds, subject to IC. Now IC is that set of initial conditions. So I'm basically telling it, solve the differential equation for every single one of those initial conditions that I've put up there, and then plot the results. So let's go ahead and stop there and plot them. Alright, there's a whole lot going on here, and we're gonna understand this a little bit better later in the semester, but you can see all these yellow lines represent the solutions, and all the arrows represent what's called the slope field of the differential equation. Now we'll talk more about slope fields next week, but what you need to know is basically you're looking at the solution to 11 different differential equations, all plotted on the same plot all at once. Now, there are several options that I have available to me to make this look a little bit better. I'm not a big fan of maple yellow or maple red. So I can change the color to blue, and what that does is changes the color of the arrows. So that's the color of the slope field. If I want to change the color of the equations, that is the line color command. And let's just change that to black. And let's say I don't like these arrows. So the different arrow styles, maybe I'm not a big fan of those. and I want to change the arrows over to, let's say, medium. So here's medium style arrows. Notice they look a little bit different. Or maybe I don't want any arrows at all. So maybe I don't want to see the slope field. I'll just say arrows equal none. So there is all 11 solutions to those differential equations that we looked at. And finally, let's go ahead and maybe I want to put the terminal velocity in as well. So I want to add that to my graph. If you notice, back up here when we solved the differential equation, this was the solution, the general solution here. And the general solution has a terminal velocity of 49. The terminal velocity is what happens as t goes to infinity. So what does the velocity eventually become? Well, as t goes to infinity, because it's a decaying exponential, that this whole part goes to 0, which leaves 49. So we know the terminal velocity is 49. Let's actually plot it. In order to plot it, I'm basically going to copy this DEplot command I have, and I'm going to name that plot. So I'm going to say plot 1 is all that stuff I just did. And notice it just stores the plot off to the side. For the second plot, I'm going to actually plot the line 49. And from 0 to 10, and then I'll give it a good range for the V. And let's say I want this line to be red, and the line style, let me make it a dashed line. And so there's plot 2. Let me go back up and suppress the output here on plot 1. So we've got two plots that are stored. They're stored in the memory of Maple. If I want to plot them simultaneously on the same set of axes, then the best way to do that is through what's called the display command. Now, the display command was the reason I needed to load the plots package. The display command does not work without the plots package loaded at the beginning. So the display command, I'm going to, in curly braces, say plot 1, plot 2, and that's going to plot both of them together. And then you have the optional ability to create what's called a view window. And the way that you do that is through the following set of commands. As you might imagine, the way that these commands work is 0 to 10 is the range for t, and negative 25 to 50 is the range for v. And so if I hit enter at this point, now I have all 11 of the differential equations that I solved plotted, and then I have the terminal velocity plotted at 49. So you can see that terminal velocity acts as sort of an asymptote for this set of equations. Now we're going to do a lot over the semester with plotting things in Maple. It's one of the best ways to visualize what's happening in a differential equation setting. This is just sort of your first glimpse at that process specific to the dsolve and the DEplot commands. In the future, we'll add on some more commands to this, but for the first month or so of the semester, these are really the two commands that you need to get comfortable with. All right. Thank you for watching.